To evaluate the effectiveness of an anonymization algorithm, various subjective and objective methods have been proposed. Evaluation methodologies depend on the privacy preservation scenarios. In this work, we focused on subjective evaluation and considered the scenario of an attacker attempting to access a set of original and anonymized utterances from multiple speakers. Our goal was to examine performance accuracy when evaluators were tasked to link natural and anonymized speech recordings. Evaluators were tasked to listen to speech recordings and group them into clusters according to their perceived similarities. To do this, they used a custom interface developed at the Laboratoire Informatique d'Avignon. As seen here, the interface was accessible from a standard web browser. Each trial was composed of 16 different chunks spoken by 3 different reference speakers and 1 distractor. The reference speakers were assigned between 2 and 6 different chunks. 1 control trial was composed of only natural speech recordings. 2 evaluation trials were composed of 8 anonymized chunks by reference and distractor speakers. All anonymized chunks were processed by the same baseline system. To compare subjective evaluation metrics, we use an ASV system that relies on X-vector speaker embeddings and probabilistic linear discriminant analysis. The ASV system was trained on the LibreSpeech dataset. The ASV model was used to obtain PLDA scores for evaluating pairs of speech segments. As defined in the slide, the PLDA scores were computed as log likelihood ratio values between corresponding X-vectors. To examine the effect of anonymized speech, for each evaluator we calculated a difference between their performance during the control trial and their mean performance during the evaluation trials. Mixed ANOVA procedures were applied with anonymization system and language as between subject factors. Our results are illustrated in the table. For mean F1 difference, we found a main effect for language, but no other effects on system. Post-hoc t-tests showed non-native English-speaking evaluators were more affected by linking natural and anonymized speech recordings than native English-speaking evaluators by approximately 7%. This result is illustrated in the figure. For the evaluation trials, Pearson correlation procedures were applied between PLDA log likelihood scores and mean F1, mean purity, and mean listening count metrics between systems and native and non-native English-speaking evaluators. The table illustrates our row coefficients and p-values. As we can see from the figure, there is a strong and significant correlation between objective and F1 metrics for the B2 system, but this is not the case for the B1 system. This study demonstrated that evaluators were able to use a clustering interface to link natural and anonymized speech recordings based on their perceived similarities. We reported no significant differences between systems across its subjective metrics. However, we observed a significant difference between native and non-native English-speaking evaluators for mean F1 difference between control and evaluation trials. Thank you again, and we look forward to responding to your questions and comments.